Okay, so for this second video, again, make sure you have something to take notes because it's probably going to be very helpful. We're going to do this quadratic application problem. Okay, and these are the second types of things on there. Now, in this problem, we kind of want to read through because we're going to get some information about this. And so it says, while on the Audubon field trip, Jennifer sees a red-tailed hawk drop its prey. And the height of the prey in feet is given by this formula. And they want to know how long it takes for the prey to strike ground. And they also want to know the maximum height. So, first thing I want to think about is how the prey kind of goes. Which, let's say this is the ground, and a little dot is where the prey is. So let's say the path of this is the hawk picking it up. So the hawk comes over here, picks it up, and at some point at the top, which we'll put in blue, at some point there, it drops it. Now when it drops it, since it had kind of this speed, it's going this way, it doesn't go straight down to the ground. It's kind of got some of this momentum, so it's going to kind of curve back down. And it's going to hit the ground right here in red. So you can see that this makes kind of a very, very, very nice arc shape or parabola. And so there's two things we want to find. We want to find when it hits the ground, and that would be its x-intercept of this thing. And we also want to find its max. So let's start by finding its x-intercept, because that's the first thing it wants us to find. Now we learned four major different ways to find this. We could use solving, we could do factoring, we could use completing the square, or we could use the quadratic formula. Now when I look at the equation that they gave us, solving's right off the table because it has the term. Factoring's off the table because it has that right there. Completing squares off the table for me because I'd have to divide this 48, even though it's even, by this negative 16, and I am prone to get decimals and different things. Also, I know for a fact negative 16 is going to divide 50. So I'm probably going to use the quadratic formula to find my answer. And if you remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to use this to end up finding your answer. So I'm going to get the clutter off the screen, and then we'll use the quadratic formula. Okay, so in our case, let's plug everything in. Since 48 is my b term, that negative 16 is my a term, and my c term is that 50 in blue. Let's just plug all those things in. So I'll have negative 48 plus or minus the square root of 48 squared minus 4 times negative 16 times 50 all over 2 times negative 16. And we'll start plugging that in. In my calculator, I'm going to plug this thing under the square root first to find out what that it would equal. When I plug it in, I get negative 48 plus or minus the square root of 5504 all over, well, 2 times negative 16 is negative 32. Since I have a plus or minus, I'm going to break this up into two answers. My top one being the positive and my bottom one being the negative. So I'd have negative 48 plus the square root of 504 is 74 over negative 32. And then we have the negative side, which would be negative 48 minus 74 over negative 32. And let's see what these two answers. When I plug this one in, I get negative 0.8. That answer doesn't really make sense because you can't have negative time. So that's not my good time. If you think about it, there was two spots. The first time when it was picked up, and the second time was dropped off. So this is my negative time when it was picked up. So it's before we started tracking its path. Then I got this other time, which is 3.8, about. And that would be my good time. So it takes the prey about 4 seconds after the hawk drops it to reach the ground, or however long that they were tracking this thing. So it takes about 4 seconds for it to reach the ground. So we figured out our first answer, and now we have to find this max. So we're going to find this max in red. And if you remember how we found the vertex, because that's another name for the max, it was negative b over 2a. So that's going to tell us how long it takes for it to reach its max, and then we'll plug that in to find the maximum point. So in this case, negative b over 2a would be negative 48 over 2 times negative 16, or negative 48 over negative 32, which then would equal 1.5. So it takes 1.5 seconds for it to reach the maximum height. Unfortunately, that doesn't tell me how tall, so this was the seconds. So I need to know how tall, so I'm going to take my 1.5 seconds and plug it in for each of these individual t's. So let's do that. Negative 16 times 1.5 squared plus 48 times 1.5 plus 50. And when I type that all in, I find out that this equals 86. And that's my answer I'm going for. So we know it takes 86 feet for it to reach its maximum height. And we found that it took about 4 seconds, or 3.8, for this thing to hit right back on the ground. So that's how you do quadratic application problems. You just kind of look for whether it's asking for the max or for how long it takes to reach the ground. We're going to do one more example. So in this next example, they're looking for the dimensions of this plot of land. And they tell us certain things about it. One big thing is it's rectangular. So I'm going to draw the rectangle. And they tell us that the length of the land is 10 yards more than the width. So I don't know what the width is. I'm going to call it W. But I know this length is W plus 10. And they told us the area of the land is equal to 600. Well, area is just length times width. Or in this case, area is equal to width plus 10 times width. And we know the area in this case. The area is 600. And we can do this, which would give us W squared plus 10W is equal to 600. So the first thing I'm going to do is I'm going to make this look like a quadratic equation. And how to make that look like a quadratic equation is subtract the 600 over until we'll get 0 equals W squared plus 10W minus 600. Now again, we want to figure out what W is. So to figure out what W it is, we have a couple different ways. We could use factoring, we could use quad form again, like we did in the last problem. We could use completing square, which might be nice because this is an even term, but we can't use solving because it does have a b term. I'm going to use factoring because I know what this breaks down into. So when we're factoring, this breaks down into W and W. And since it's negative 600, if you took positive 30 and times it by negative 20, now we'll break this up and say that W plus 30 equals 0, and W minus 20 equals 0, and I would end up getting that W equals negative 30 and W equals 20. Well, we do have two answers, but one answer doesn't make any sense. The width can't be negative, so it has to be 20. Well, if the width is 20, the length is just 10 more. So the length is just 20 plus 10, or 30. So those are the two dimensions that we would get. So the big thing is you want to set up the problem. Since this is an area problem, we do the length times the width. It just happened that in this case that the length was just W plus 10. So when we multiplied that out, we were able to figure this out. We used factoring as our method. You could have used completing the square. There's a couple, or quad form if you wanted to. I think factoring is the quickest. And we found out that our width was 20 and our length was 3. So try a couple of these problems.